All right, everyone, welcome to another episode. We are doing things a little bit differently here. I'm on the road and I'm doing my best to try and get this content out, so I apologize in advance for any lax editing. And I'm trying to fix the volume levels, but I'm also trying not to yell because I'm in a co-working space. So here we are. The lighting is going to be a little bit different, but what I want to do is I want to show you step by step how to make these radio frequency sensors that I've been talking about, and also show you how easy it is. I'm going to use nothing except for 3 Raspberry Pis and a couple of other little adapters here and there. But I'm not using expensive computers. I'm not using anything other than these things that you're gonna see here on the screen, and I am doing it on the road, out of a bag, from some random co-working space in some random city. So if I can do it here, you guys can do it as well. Please follow along. Let me know if you have any questions. And also, I guarantee that you can do this better than I can. I have a limited amount of time, limited amount of energy I can pour into this, but if you want to improve it, make it better, by all means, please do make it better. And here we go. We are going over the setup. As you see, I have 3 Raspberry Pi and a bunch of little adapters. We have this Raspberry Pi, which is running on the official Raspberry Pi screen as a regular Ubuntu desktop environment PC. This is a regular computer. You can replace this with a regular computer, but I wanted to use Raspberry Pis for everything. This here is a Raspberry Pi converted to become a router by using OpenWRT. I have firmware images for this on my GitHub, along with an instructional video, which you may have seen before, that shows you how to turn a Raspberry Pi into a router. Over here, I have the Raspberry Pi that is going to be turned in to the sensor using Kismet. I have a little 3.5-inch screen because the next version that I am making is going to have a status screen displayed, kind of like the old text style status screens, that's going to tell you what is going on. There you go, 1 Raspberry Pi, 2 Raspberry Pi, 3 Raspberry Pi. And then I have my adapters. The adapters that I'm going to use for this, you can use whatever adapters you want to use. I like using a Wi-Fi adapter, an RTL SDR for 315 megahertz, an RTL SDR for 433 megahertz, and a Zigbee. I chose Zigbee because, of course, you only have 4 ports, so I'm limited to 4, and I like Zigbee because a lot of the home security systems run on that, and any Zigbee anomalies could be detected by this little adapter. If someone was trying to mess with your alarm system, like take it down or something, wouldn't it be good to know what time they tried to take it down and which one of the sensors they tried to take down? Alternatively, if you want, you can also add GPS to it. I'm adding that in the next version, so I just wanted to throw that out there as a preview, but that is all I am using. The reason I need this router is because I need internet access in order to load the packages, because we're doing all of this from scratch, and I need this and this to be on the same LAN. The reason I need them to be on the same LAN is because, to make it easy, I have temporarily enabled SSH on this Raspberry Pi. This Raspberry Pi is Ubuntu 24.04.4 server. This is Ubuntu 24.04.4 desktop. The only difference between these two is this one has SSH enabled and was pre-configured with the username and password that I have set just so my scripts will work. This one is just a regular out-of-the-box computer. This is a router. There you go. That's all you're going to need, and let's dive in. All right, we're going for a speed run here. First step, and we're doing exactly what the GitHub stuff says. All of this here is in my GitHub, so we're going precisely off of this. And I'm going to show you how I got some of the commands. The first thing we do is we want to install Kismet. So we're going to the actual Kismet website, Kismet packages. So ours is 2444. Remember I said it's 24.4? There it is right here. So what we're going to need is these commands right here. The first one. So we will just copy this first line all the way till the end. There it is, till null. Copy. So in my case, the way I got the IP address was I went to my router's admin page. As I go to my status, I go down here and I see, there you go, Kismet sensor 192.168.4.154. So then I'm going to SH into that. Here we go. I'm going to log in. Remember, the username is the UTS guy. That's because I set it that way. If yours is root, if it is Ubuntu, if it is something else, that's fine. We're going to SSH into there. Password is 12345. That's what I set it at. If you set your password at something else, that is perfectly fine. I'm in. The first thing I want to do is I'm going to paste those commands that I got from the Kismet website. Bam, password. And remember, it's got to be hooked up to the same LAN, and that LAN has to have an outbound internet connection because that is how you are going to download the packages. After it is set, you no longer have to connect it to the internet ever again unless you want to update it or do something else to it. There we go. That's the first one done. Then the second command from the Kismet website. There we go. Then back to Kismet, and next, these are pretty easy. It is sudo apt update, and then, so I'm going to fast forward some of these because it might take a little bit. It's just doing its thing, fetching all of that. You see, package list comes up. I'm just letting it go in real time, and I'm going to try to time lapse it for you. There you go. Don't install all the upgraded packages. We don't need to go there just yet. We need to then go to sudo apt install Kismet. Bam, and now you're gonna get a manual prompt. You're gonna see the manual prompt, there it is. You hit yes, and then you're gonna get one more. It's gonna be very important that you do this one accurately. It's gonna ask you if you wanted to install it using the suid helper. Yes, you do. Or SUID, however anyone wants to pronounce it is okay. There it is. So this is all done here. I'm just going to the GitHub page so that I can cut and paste directly from it. Again, I recommend you do this on a bigger monitor than this tiny little thing here. But here we are, here are the commands. So these were directly from there. We did these guys. So let's now, this next line, let's copy that. And then let's paste it right in there. I'm going to try to time lapse some of this so you are not sitting there waiting for it. All right, and we're back. It'll take a couple of minutes. Again, these are just Raspberry Pi 4Bs, so sometimes this will take a little bit and then it is done and we're off to the next one. Okay, we already did Kismet. Now we need to add ourselves here to this group in order for us to be able to run Kismet without having to do it en route. This is a very important step because otherwise you have to run it from root and it's gonna be a pain in the butt and that's not gonna work out for us. Next code here. Again, I'm cutting and pasting directly from the file. So that way I make sure that you guys are doing what I'm doing. Now we're gonna create this directory. This directory is so we can store the logs. I'm working on automated retrieval. So the logs must be stored in that directory, and we're gonna accomplish that using these codes. We are then going to modify the Kismet file. The Kismet configuration file is what tells Kismet, hey, you have the following adapters that you're able to use for the following things. So we're gonna modify that file, and we're going to add these lines to it because we are specifically configuring our sensor to have 5 inputs or 5 data sources. Those data sources are the Wi-Fi dongle, the 2 RTL SDR dongles, one for 315 megahertz, the other for 433.92, the Zigbee dongle, and the internal Bluetooth. So we're going to copy that and we're going to paste it into that file. We're good to go there. Then we're gonna go back a little bit. So when you're in Nano and you finish modifying your file, cutting and pasting, I personally like to use the Shift Control V. Shift Control V will paste something into the terminal. You can't just press Control V. If you press Control V and you're in Nano, watch what happens. That's not what you want to happen. You don't want to move. What you want to do is you want to paste stuff. So Shift Control V will paste. Then to save something in Nano, you have to press Control O, and it's going to ask you to write. You press Enter because you don't want to change the file name, Enter, and then Control X. So to save in Nano again, that is Control O, Enter, Control X. Next step in the GitHub. We are now going to modify the logging file because we want our logs to do something specific. Again, in the terminal, Shift Control V pastes it. And let's see what modifications I told you to make. I told you to make these modifications here. We're going to make these modifications, but we also need to delete or comment out the existing modifications there. I'm going to make one change to this, or let you decide if you make a change. The log type is pcapng because most people I know are going to view these in Wireshark. If you would like to view these in an SQL browser, then you would change this to Kismet. In our case, it is pcapng. So let's find log title prefix log type. So let's find over here log title, right? We already had it up there, so we comment it out. Log prefix, we have it up there, comment it out. Log type, we had it up there, comment that out with the pound sign. Going down here, what else we got? Nope, let's keep going. So far, so good. And there we go, we got to the end and everything is all set up. Let me explain to you what's going on up here. The title is going to be the title of the file name. So every log is going to be UTS_Kismet_, the date and an identifier for the log. The prefix is the directory in which the logs are going to be stored. Remember, we created that directory earlier called UTS_Kismet_logs, and I preset the username to be the UTS guy. You can change all of this to whatever you want. I just am standardizing it so that way everyone can do the same thing, and I can help troubleshoot if needed. How do we save in Nano? Again, Control O, Enter, Control X. There we are, next step. We need to install the driver for the alpha antenna that I like using. So we are just going to install that sucker real quick. And we are going to time lapse this a little bit for you. We're going to travel in time. And we're back. Next step. Here we go. We're going into the directory that we just downloaded from GitHub. So what we did here is we downloaded the drivers from this GitHub, and now we went into the directory where those drivers were downloaded from, and we are going to make and then sudo make install. We're going to travel through time again because this might take a little bit. Compiling it takes a little because these are not high-powered computers. They are cheap Raspberry Pis. Well, not cheap anymore. I just went to the store and they were triple the price that I paid for them. Crazy. I should have just invested in Raspberry Pis instead of gold. As you can see, that took a little bit to compile, but that's just what happens. No problem at all. We go back to the next one, which is sudo make install. Sudo make install. Oh, I forgot I said I'm going to cut and paste. That was the whole point of cutting and pasting directly from the GitHub to make sure that you all can do it as well. And let's see what our next step is going to be. This is going to be the disk cleanup script that we are making. What I've made this do is I made it so that after your disk is 90% full, whatever that is, then it is going to delete files until it goes below 90%. So if you need all of your logs, you need to manually pull the logs down. I'm working on automating this, but what I'm trying to do is I'm trying to make it so that you don't have to connect this to the internet. If I were to automate this, it would have to be connected to the internet somehow, and I'm trying to prevent that because the whole point is for you to be in control of this. But part of that control is you opting to put them online, so I want to give you that ability. But for now, this script is just going to delete files when disk usage reaches 90% or greater. Cool, so we are done there. Let's go back, and we want to create this file, create it, and then we are going to paste everything that is in here, including this bin bash, and that has to be the first thing. And you're going all the way down to this FI. Copy that. How do we paste into Nano? Shift Control V. How do we save in Nano? Control O, Enter, Control X, and we are great. We're out. Let's keep going now. We want to make this file executable. What this command here is doing, it is making sure that we can actually run this as a program. So we run that. There we go. Next one. we need to modify the cron tab. So what cron tab is a program that runs in the background that runs commands both as the user and as sudo. It can run them sudo and it can run them not as sudo. We're going to have a couple of helper scripts in the background of our cron tabs, so we need to put them in. We haven't made this script yet, but we are going to make it. I recognize it's a little out of order. Bear with me, but they will work even if you're doing this out of order. We're going to make this script. This script does not yet exist. We are going to make it. First, sudo cron tab e, enter, and it's going to ask you which editor would you like to use. I use Nano, so I'm going to select one. There we are. And I'm going to make some space up here because I need to paste the following thing in here. What this is telling me is every time that this script or that this device reboots, it's going to run Wi-Fi Bluetooth helper.sh. This is a script that grabs the name of your Wi-Fi dongle and tells Kismet that is what it should use. Wi-Fi dongles have different identifiers and different names, so that way you don't have to use the alpha one that I'm using. You could use whatever the heck you want to use, and this script will pull that off. I was also going to do this for Bluetooth and the Zigbees, but I didn't have to, but I leave that there and call it Wi-Fi Bluetooth helper because I eventually want to do some more stuff with Bluetooth, and this will incorporate later. But for now, let's just go back into the cron tab. Paste. How do you paste into Nano? Shift Control V. How do you save? Control O. Enter. Control X. And we are good. Let's keep cranking away here. We're going to now edit the regular cron tab. Regular cron tab is going to run as the regular user. You press 1 again for Nano. And we're going to add all of this into our cron tab. All of these 3 lines get added into the cron tab. There we go. Control O. Enter, Control X. Got it. Now let's keep going now. Now we're going to create that Wi-Fi Bluetooth helper script. Let's go in here, create that, go back into the GitHub, and you have to have this bin bash thing has to be at the top. If it is not at the top, it is not going to work. We're going to go all the way down to exit 0. There we are. Control O, enter, Control X. Great. Back to this, make that executable, copy it, there we are. And now it's executable, cool. Couple more steps. What we're doing now is we're going to remove that SSH server. We're gonna remove it, so we're gonna press and type that in. I would wait to do this until you realize that everything works. So let's hold off on that final command. We're holding off on that final command right there because we want to make sure everything works. How do we make sure everything works? Well, now you are going to do the following. Now comes the fun part. We're going to plug in all of our dongles. Let's plug in all of the stuff. We are getting to the cool part. We're putting in our adapters. They are lighting up. Where should you plug them in? There we are. There we are. So we have plugged in all of the adapters, and to make sure that it works, what we are going to do now is we are going to reboot it. How do we reboot it? Well, you can just unplug it and plug it back in. That's all you do. Unplug it, and then plug it back in and give it a second. Now that it's booted up, you're going to go to its IP address, but you're going to go in the web browser. You're going to go to 192.16. In my case, in your case, it's going to be different. Whatever the IP address is, you can find the IP address by going into your router, or you can run an Nmap scan to see what is open. 168.4.154. I went into the router, then :2501, because that's the port that Kismet runs on. And is it working? Yes, it is working. Look at that. We have a Kismet instance. So pick your username and password. I am, of course, picking a very, very difficult username and password here. I'm kidding. I'm just doing this for demo purposes. Then save it. Remember that username and password. You're going to need to remember it. Hit continue. Whoa, I already see everything popping up. Let's look over here at my sources. Let's see if all of them are working. Data sources. And look at that, 1, 2, 3, 4, 5. All of the data sources are working. Everything is automatic. You're already seeing all sorts of activity. Look at this. You have all of these devices here. We got pages and pages of devices. Everything, all of this is already being recorded to your logs. And it's gonna keep doing it. You reboot it, it'll do it over and over again. Let's SSH into there again, just to show you that the logs are being populated. And of course, we're going to disable SSH as the final step, but I just kind of want to show you a little bit about what's going on. So let's go ls cd. See, the Wi-Fi Bluetooth helper script is there. The disk space check script is there. Let's go to UTS Kismet logs. And there you go. See, it's already creating the logs. This is automatic, gang. It's going to work. So we can kill the SSH access, which I certainly recommend, but that's it. There you have it. Let's do a little bit of searching on this. Let's look and see what RF sensors I have. Whoa, I'm already picking up some tire pressure monitoring sensors. Check this out. You click on the TPMS, and then you can actually see someone's tire pressure and the temperature. Crazy, right? Let's go and do some Bluetooth devices. Look at this. You can tell all sorts of cool stuff from this. And then Wi-Fi is the greatest because when you go to, let's do Zigbee. Let's see what we got in here. So you can also view not just by type of device, but by data source. You see, these are the 5 that we have. This is the onboard Bluetooth. This is the Zigbee. This is the first RTL SDR dongle. This is the second RTL SDR dongle. And then we have our Wi-Fi. Sorry, my mouse is screwy. It keeps moving around. Let's see what the Zigbee is seeing here. Boop. Look at that. There you go. You start developing a baseline in your home, which is the key. You want to know what your home regularly does. You can run these logs through AI. I have a year's worth of logs that I have used. I have nothing against running this into AI models if it's appropriate, if it's private, if heck, it doesn't even have to be private if you don't care. The point is you need to make an informed decision as to what you are doing with these. I ran an offline model and I gave it a year, almost a terabyte of logs from my house. And then it was able to establish a baseline and start picking out anomalies. So now what I'm doing is I can get an alert when there is an anomaly near my home at a time that I see fit. I want to know when anomalies appear anytime when it's dark, right? I get it during the day, even early evening, people are coming in and out, but when it's nighttime, there shouldn't be a lot of movement. So I want to be alerted on anomalies. Then we go down to Wi-Fi and look at all this awesome stuff. What I want to show you is, look how easy that was. We did this together, cutting and pasting from the GitHub, and now you have access to this anytime you want. All you have to do is make sure that you have the computer that you are on, which is this one in my case, it's this Raspberry Pi thing here. You need to have that computer and the device itself plugged in to the same LAN, and then you open up a web browser and you go to the IP address of the device, :2501, and then you're gonna see all of this. To pull the logs off, as you know, you gotta pull them off any number of ways. You can use SCP, you can plug in the USB like I outlined in the video, the episode 16 of last week in UTS. You can even put a GUI on this. As I mentioned, I'm working on adding a screen, a status bar, and even automating the throwing the logs onto a USB. So stay tuned for that. If you want to work on it, go for it. But that is it, gang. Look at that. We did it all within a reasonable amount of time. It works. Please, comments, let me know what you think.
Dylan! You son of a bitch!